Just gonna wait for people to filter in, since I think some of the motivate, like I'll start by talking about some of the motivation for this work, and I think if people come in later, I'll have to repeat it. So I'll just wait for people to filter in before I kick it off. But in the meanwhile, we can chat on the text chat if anyone wants. How's everyone doing anyway? In Seattle, it's a very beautiful weekend, but it's been extremely warm. I think the temperature right now is getting close to 90, or at least it was almost at 90. Let's see what it is right now. Okay, it's 87 right now, which is freaking hot. Like, I don't have AC in my house, and I had one fan, but it was terrible, so I turned it off. Alright, I'm just going to try to bring up an incognito browser, since maybe I will want to... Oh, you're sitting in front of a fan, can barely hear me? I'll try to speak up. I think I was mumbling a little bit. Um, yeah, let me know if audio volume is acceptable to folks. I think it's my normal settings, but there's always a chance something regresses. This project was a little bit weird. Like, this was originally I thought of doing this on stream, like actually coding it on stream, but I realized it's like 80% design and just thinking and noodling with details, and maybe 20% actual coding. And some of the coding involved UE4, which is not exactly amusing to behold. It's a lot of slow compile times and random bugs. So decided to just basically do it off stream, kind of like I did the B-tree stuff originally, and then walk over the salient details and maybe some comparative analysis of different approaches to the same problem. But yeah. So this is my little stupid scene renderer. With a stupid FPS camera and a stupid recursive scene graph renderer. Um, but I guess it kind of gets the point across that it's really easy to just process this kind of data. All right. I think I'll just dive in, and then if people show up later, they can watch the archive or the YouTube video. So yeah, what I want to show off today is, I guess, a few different things. Primarily, it's really about the design, the technical design uh, of an asset format for kind of real-time graphics. Basically, sort of a scene graph format for runtime use, not like interchange between DCC apps, but primarily between a real-time renderer and some sort of maybe a real-time rendering toolchain, but not like completely offline-centric DCC tools. So um, before I go into that, I want to talk a little bit about kind of existing approaches that are out there. And some of them are kind of real-time centric, and others are not. So for example, let me just pose you a question, right? Like if you wanted to, suppose you're writing a renderer, and maybe it's just for experimentation, and you would like to render some static meshes in some kind of transform hierarchy, and you'd like those meshes to have materials applied, and you would like there to be lights, and you would like there to be, to get a little bit fancier, you'd like there to be skinned meshes, and maybe you'd like the skinned meshes to have animation. Um, and this to me seems pretty straightforward, right? Like it shouldn't be hard for people to export that kind of data and get it into your testbed app or something. But right now, it's actually kind of a nightmare, and has been for a long time, and hasn't really improved much in that respect. There's been progress, but nothing that I'm super psyched about. So in the olden days, what people would do is they would, they would typically use something like they would write a simple loader for the Wavefront obj file format, and this is like a simple line-based format that requires fairly minimal post-processing in order to be ingestible by a real-time renderer, like an OpenGL style renderer. So this is sort of the old standby if you want a static mesh format. And there's been sort of unofficial extensions to it since then to cope with like vertex colors and things like that, which are not officially part of the format. And nowadays, I guess, there's the tiny obj loader single header file library, which I have some qualms with, let's just say. But anyway, there's easy ways of getting this into the engine that doesn't draw in a giant SDK or anything like that. So if you just wanted a mesh, this was good. This is still pretty good. But anything beyond this, and it gets dicey. If you actually want something like a full scene graph with transforms, already it gets dicey because that's not something you can use for this. And someone's saying a text-based format for decimal numbers sounds like a bad idea. Yeah, that sort of is a foreshadowing of things to come. ASCII formats that use decimal representations are problematic, to say the least, for true serialization. But anyway, so yeah, like people use Wavefront object files for like simple meshes, but there's no real scene representation that would, store like transform hierarchies and stuff like that, and other relationships, and also just store more complicated data like skinned meshes or lights or stuff like that. So back in the day, what people would do, and I think still do, but it's becoming less common, is that they would just write custom exporters for the DCC apps that their game studio used. So, you would write something with a Maya C++ API, or I guess nowadays people just use Python. But back in the day, typically these apps had either a hardcore C++ or C API, and then they had kind of a toy API using a scripting language. So, for example, for Maya, that's Mel, or was Mel. I don't think people use Mel anymore. For 3ds Max, it was MaxScript. But people normally use sort of hardcore C and C++ code for that, and it was a pain in the ass. So someone's asking me to turn up the volume a tad. Yep, I can do that. Is this better? I can also just speak louder. So anyway, people would write custom exporters, and it was generally a pain in the ass. One, because those APIs of the various DCC apps like Max and Maya is kind of awkward, and also irrespective of specific API differences, there's a fundamental mismatch in terms of how a DCC app like Maya or Max views, say, a mesh and how a game engine views it. So for example, the classic example I always bring up is anytime you want to represent discontinuous vertex attributes. So either because you have smoothing groups where you need to split vertices so that they can have separate normals for separate for separate faces, or because you have different materials and across a material group you need to split for, say, UV coordinates or other material properties. The way those things are usually represented in a DCC app is quite different from how you do it at runtime. So at runtime, it's no problem. You just duplicate the vertex attributes in the vertex buffer, and then you're good. So there's really no issue from the runtime perspective. But from the sort of offline mesh processing perspective, you typically want something a little bit different. Like, for example, actually, if you want to read about this, a good place to go is Fabian's blog. He has a series on mesh processing it starts with half edge and goes to some adjacency-based stuff that he went to later in their demo tool. But anyway, this is a good place to read about how you have to deal with stuff like vertex attributes in a mesh representation. But for rendering, normally you don't care about this. You don't want to use it. You just want something like vertex buffers and index buffers. You duplicate stuff in the vertex buffers. Everything's great. That's like one mismatch, and so that's just an example of, like, aside from having to write custom exporter code for all these idiosyncratic APIs, there just tends to be a basic data structure mismatch, and so that basically necessitates you to write a bunch of code to do sort of like various kinds of maybe welding or unwelding or various kinds of splitting things, and maybe you also have to deal with triangulating things, or just all these things you have to do to prepare things for runtime use. So that was a pain in the ass. And there were things like back in the day. I remember using this thing by Pierre, which was a like an open source plugin. Was it open source? No, I actually think it wasn't open source. It was just free as a binary. But it did a bunch of the stuff I'm talking about for Macs. But people generally wrote this in-house, and it used to be such a problem to write and maintain these things for all the different DCC apps that I know for a fact that a lot of people bought Granny from Rad, mainly for the exporters, so they didn't have to deal with that in-house. So this has sort of been a continuous problem going back like basically decades in the industry. It's kind of incredible that it's as bad as it is. Um, and then I don't know when this really became a true option, but it seems like maybe 5, 6, 7 years ago, people started using FBX instead. So FBX is, in case you guys don't know, it's a scene file format, I guess originally for Filmbox. But then I guess when Autodesk bought them, it sort of got co-opted into being the general Autodesk scene file format. And FBX, even though it's DCC centric, it's very complete in what it stores. Um, it has some nice extensibility properties, but I mean, there's two issues for kind of game use. One of them is that the data is still very far from game ready. You still have to do significant processing, although the SDK does some of that for you. Um, but I think the bigger problem really is that FBX is not free. Like it's controlled by Autodesk. It's not even a file format in the traditional sense. It's really more of an SDK that happens to sit on top of a file format. But because everyone uses it through the SDK, there's really no stable file format you can code against. I think there's a basic framing XML. There's basically this binary XML-like tree structure that's the skeleton of the FBX format, but the actual details of how that skeleton is filled in and how to interpret that tree structure, all of that can potentially change completely from version to version, because they can basically prevent backwards compatibility breakage by just writing separate code paths in the SDK. So there's some weird incentives here in terms um, of kind of lock-in and stuff, vendor lock-in and stuff like that with FBX. But I do actually think it's an improvement in terms of nowadays, if you want to move data between apps, FBX is really strong, and that's true even for non-Autodesk apps. Like, so if you're using Modo and you want to get stuff back and forth, you can use FBX. I think that's what everyone does these days, and it also works for getting things into games. But it's not open. It's a really heavyweight API. It's super bloated. You're subject to their license terms. So, for example, I know that Blender had an issue where I don't know what they ended up doing, but for a long time they were looking at either writing their own independent implementation of FBX, or they were trying to use a separate process so that they could sort of get around the licensing terms, because I believe Blender is GPL or LGPL maybe. But anyway, so FBX has a bunch of issues of that sort. Um, so what other options are there sort of in the DCC space? Well, the closest thing in some respects is a format like Alembic or Alembic Cache. So Alembic is sort of designed for not for true interchange in the FBX mold, but it's designed to basically, here's an example. Suppose you have a fluid simulator and you want to bake out the mesh data every frame at 30 frames a second or whatever, and then you want to be able to render it in another renderer. Now, in that case, you don't really have to capture the detailed, say, fluid simulation metadata or whatever. You really just want to bake out the mesh and then punt it over to the renderer or whatever other app in the chain needs to process that data. So Alembic Cache is sort of flattens out a lot of the data that you have in a DCC app, but it still retains basic stuff like a scene graph hierarchy for transforms, and it supports data types like polygonal meshes, materials, and things like that. Um, all right. Next up, Collada. Collada is infamous in the game industry. I think Collada, FBX probably predates it by quite a bit, but at least FBX as an actually widely used, kind of interchange format, I would say, at least in my consciousness, if not in reality, happened later than Collada. So Collada is like a mid 2000s effort to basically develop in a consortium a like the kind of scene interchange format I've been talking about. It has a whole bunch of issues, and they're actually kind of symptomatic of things I'm trying to avoid in my work. So it's maybe good to talk about it. So first off, it's trying to be sort of a universal interchange format. And there are aspects of that ambition that are just fundamentally contradictory, and if you try to pursue them, you end up in a very bad spot. So, for example, suppose you have two different apps and you're trying to interchange data that is fundamentally incommensurate. So maybe they have different notions of what a material is. There's no way you can bridge a gap, a semantic gap, with a file format. You just can't. So typically what you end up having to do is either not represent that data, or you have to represent it but in a way that's not truly interchangeable. So for example, maybe a Maya material and a Modo material aren't mutually expressible in terms of each other, but you can both store them inside a Collada file or some other file. And the best they can do when processing such a file is just to ignore data they don't understand. But fundamentally, they can't work with each other's data if it's not commensurate with their mutual understanding of what, say, a material is, or what an animated mesh is, or whatever the data type may be. So that, I think that's one of the basic issues with this grand ambition. So that's number one. The other one is, even though it was sort of pushed very widely as a well, actually, let me go into the superficial aspects that everyone complains about. It's XML. So it came out in the, I would say, sort of the tail end of the XML hype phase. I want to say XML hype was sort of like late 90s, early 2000s. This came out sort of early to, yeah, like mid 2000s, but it used XML. And I guess the thinking that drove it, actually, I have a quote that I posted earlier on Twitter. Um, Let me just dig it up. Actually, let me dig up the document. Here we go. So just for fun, I dug up the spec and like look at these introductory remarks, which are really setting these are like the design pillars that drive the requirements. And these two are fundamentally kind of awkward. Well, it limits its use for some of what I want to use an asset format for. On the one hand, they say, this is not a game engine or runtime delivery format. All right, that makes, I can buy that it's not primarily designed for that. And then they say, games will use something proprietary, sized, optimized, streaming friendly binary files. And I'm like, yeah, okay. I mean, that's kind of true, but it doesn't mean that games can't or won't or don't need a something like this to talk to each other and to talk to DCC apps at some level. And then here's the one that I posted about on Twitter, which is a ridiculous non sequitur. So this is basically their argument for why you need a human readable text-based format. And it's all based on this weird notion that artists and end user will actually want to poke around in the file format like manually with a text editor, which is completely absurd. Like no one does that. Like that's something you do maybe if you're a programmer, and you're trying to debug shit, but it's not something you do if you're like an artist and you're trying to model a mesh. You don't go and do grep on vertex coordinates or some shit like that. So it's completely incoherent. But anyway, so it's XML based. In theory, that has some nice properties in terms of extensibility. In practice, like I said, the issue with extensibility is not really superficial about like syntax and encoding. It's about meaning, right? Like, so again, if you have two different notions of what a rendering material is, no level of extensibility at the syntactic or sort of skeletal level can really bridge that gap. So that's one of the issues with Collada. There is a common subset of things you can encode that other apps will, kind of different apps will know how to interpret in their own terms. But then there's a lot of other stuff that can't be encoded in terms of any of the standard types. And they just and so those apps to use Collada end up having to use their own custom node types. And in doing so, they render that data incomprehensible to all the other apps. And so, that's basically the issue with this dream of universal interchange, is that it only goes so far. And it's not worth sacrificing, say, the advantages of binary just to pursue this hopeless dream, in my opinion. And also, as I'll get into, binary formats are just as extensible as text formats. So that's also a mirage that XML is somehow superior in that respect. But anyway, and just as a classic example, by the way, it's a little bit superficial, but it's sort of a standard thing that people bring up. And it relates to what someone said on Stream Chat earlier. And that's that if if you're using XML to encode, say, vertex coordinates or other floats, you have to express them in ASCII somehow. And the standard way this was done, and still is done in Collada that I know of, is in just like decimal floats. And the problem with decimal floats is twofold. On one level, it means that you have to be very careful about how you do your reading and writing. It is, unlike what some people think, it is actually possible to do a sort of round-trippable lossless encoding of, say, a single precision or a double precision IEEE 754 float in ASCII with decimals. You just have to be very, very careful. And in particular, there's no guarantee that printf and scanf or the corresponding, like stir to D or whatever, there's no guarantee that these functions will actually be round-trippable. So what people are likely to do is they will use something like printf and scanf, and they'll just assume that this is like a lossless round-trippable process, but in fact there's no guarantee that it is, and it definitely won't be in general. So that's kind of one issue with that. The one thing you can do, which is an improvement, is to use a sort of essentially a binary encoding of in ASCII. For example, rather than storing the decimal sort of floating point representation, you can just store hex floats. So hex floats is just basically, for a single precision float, you take the 4 bytes that are the IEEE encoding and you represent it in hex in ASCII. So like 0x and then a bunch of hex digits. Anyway, so that's surmountable, but it's kind of silly that you even have to worry about this to work with floats in XML. And also it's slow, right? Like reading stuff in ASCII is usually needlessly slow, especially for bulk data. So Collada has like an infinite list of problems. I've actually been told, although I can't confirm firsthand, that the practical issues around Collada progressively got better. So certainly in the first several years, I know that UE3 had a Collada importer, and I remember it being a huge beast with all kinds of edge cases and handling issues. And that's not even addressing the DCC side of that, which was equally insane. But I've heard that like in the last few years, things have gotten better. Although just as FBX became kind of dominant, so I don't know what that really means. But anyway, this is a little bit rambling. I want to cover a bunch of different things. So yeah, that's Collada. Has some issues. Now let's talk about stuff that's more directly designed for game use. So one example, which is pretty good, at least if you buy into the premise, is Eric. I actually don't know how to say his last name, Lengiel or Lengiel. No idea how to say his name. A game developer. So he wrote this, I think, on the basis of a Kickstarter or an Indiegogo campaign. But basically what he did here is he designed this asset format and a bunch of corresponding exporters for common DCC apps. And let's see. Essentially, what OpenGX is a JSON-like, sort of generalized JSON wrapper around a scene graph. And for what it is, if you accept the premise of what he's doing, I think this is a good execution of that idea. So you have all the data types that you kind of want in a game, and they're mostly expressed in a way that corresponds to how games view, for example, vertex buffers and stuff like that. So to go back to the example I mentioned earlier, if you have discontinuous vertex attributes, you handle that just by duplicating things in a vertex buffer. And since the OpenGX works with vertex buffers, that just works out. You can also see here that it encodes floats, or at least has the option of encoding floats as hex floats. So you can see the actual encoding is this, but you can see the sort of the decimal representation in comments. Beyond that, it has some nice features like you can actually express general reference graphs by giving these names to nodes and then referring to thing by names. So that lets you do things that are not purely tree shaped, but that have like back pointers to different things. So yeah, this is I think for what it is very good. I do have some concerns, and like number one is just the fact that it's ASCII at all. I don't really buy the argument. I do think that something JSON-like is definitely superior to XML if you're going to take this route. On the other hand, I would say that the main reason for using JSON, this kind of foreshadows my gltf discussion. One of the main reasons for using JSON is that it can work with other JSON readers, right? Like it's compatible with the myriad of libraries that and languages that have good JSON support out of the box. And so by using something that's like JSON but not, you kind of lose that advantage. And so at that point, you don't have any of the kind of ecosystem advantages of JSON. You just have basically the intrinsic advantages, which in my opinion are not very significant. Um, so that's kind of one issue I have with it. And I'll also say, just in terms of, even if you accept the premise, there are some things I disagree with pretty strongly. So for example, I talked about this whole floats versus hex floats versus whatever. Let's see if I can find something about hex floats. Yeah, okay, maybe it's on the OpenDDL. OpenDDL is basically his JSON-like sort of skeleton syntax. Yeah. So the thing that I find dubious is that even though the language supports hex floats, it doesn't require hex floats. And the issue with that is, in order for me to write an app that can read an OpenGX file, and indeed any OpenDDL-based format, I now have to be able to read floats. So yeah, if I can assume that the writer and the exporter is going to only output hex float, then I can just do my hex float parsing and I'm good. But I can't assume that's the case. So this is like sort of a general point about designing file formats and protocols, is that the more flexibility you put in, the more burden you place upon the people who have to interpret that format. So if I want to do like really lightweight rendering apps or test beds, I don't want to have to handle like 5 different kinds of float encodings. So for example, I believe OpenDDL has plain decimal floats, and it has hex floats, and I think it also has like Boolean floats. It has a bunch of different encodings, and it's like this is really obnoxious to deal with as a reader. And again, the fact that I have to do float parsing means that I can potentially fall into the pitfall of doing the rounding on both input and output incorrectly. So I actually feel like this is sort of a significant issue, and without this, it would probably be, I would be fine with it. It has a bunch of pros and cons. I would say the other general thing is that the format itself is not hard to parse, but it is kind of needlessly like general for what it's trying to do, in my opinion. So, and I don't really buy the benefits versus the costs here. So even though this is good in terms of the data inside it, like the data structures semantically are fine, like the node trees, the way meshes are represented as vertex buffers, all of that stuff is kind of something that I think is totally great. I just don't like the encoding, the sort of the DDL encoding and the needless flexibility it has that forces additional work onto the sorry, I just got distracted looking chat. What was I even saying? Yeah, like the needless flexibility in the encoding that forces generality and complexity onto the reader. So I'm kind of not a fan of that. But otherwise, this is one of the best things I've seen. Actually, this is the best thing I've seen relative to the goals I'm interested in. The other thing which I only found about semi-recently is gltf. So gltf, there's a nice poster I remember seeing. Maybe it's here. Yeah. So gltf is apparently is under Chronos. So it's a transmission format that does a lot of what I'm talking about. So it's a little bit weird in terms of the encoding. So the stuff that I like a lot is most of the same parts as Eric's OpenGX stuff, which is that the way it represents vertex buffers and stuff is like the way you want it for a game engine. So that's great. The stuff that's not great is it uses JSON. Now, I actually do, like I said before, I buy the argument if they're going to have something JSON-like, you should just use JSON full stop, because otherwise you lose all the ecosystem advantages. And it looks like with gltf, one of their explicit goals was to support WebGL, and so probably they wanted to have easy parsing. You know, you can just use whatever the built-in JSON stuff is in JavaScript. So I'm not sure if that's like worth the cost, but I can at least see that they're going for something here. One weird thing about the way stuff is stored here is that the JSON file basically contains the scene graph, if you will, but then they store the geometry buffers and any animation data in this separate binary file. And then textures are also externally referenced to source file formats like PNGs and JPEGs. Another thing that's weird, and I think is kind of a regression for my uses compared to something like OpenGX, is that materials are basically expressed through shaders, and shaders are expressed directly through GLSL files. So this is great if you basically just want a way to reproduce what a GL renderer would do with the data. But that seems a little too fine-grained and coupled. Like, hey, I might want to be able to talk about, for example, this mesh has a PBR material, and these are the PBR kind of properties. Like, here's the roughness texture and the diffuse texture and the emissive texture. But I don't really want, like, for example, if I'm exporting from UE4, I don't want to have to export the whole frickin' mega GL. I guess it is HLSL by default on PC. I don't want to have to export their mega shader, because at that point, if I'm doing rendering research, for example, I'm overly tied to how they were looking at that data. I want to be able to get the data from, say, from UE4 or some other app, but work with it in my own way. I don't want to be completely coupled to the super specific stuff. And I feel like coupling to the shaders is going a step too far. On the other hand, it's Kronos. They really apparently do want to couple to GL, so more power to them. One thing that was super weird is when I was looking into this, I noticed that they have a binary, like aside from that .bin, which stores the buffers, they also have a binary encoding of the JSON file itself. But the way it's done is like, I'm like, okay, maybe this is a way to fix the issues with text-based formats for this stuff. But really all it is a direct binary encoding of JSON. So it's not really fixing the issues, it's just a slightly more compact encoding of the JSON, which is disappointing. So anyway, this doesn't address the concerns I have at all with this kind of ASCII approach. Okay, that was super rambling. Let me actually talk about what I'm doing instead of just talking about what everyone else is doing. All right. Boom, boom, boom. So to take an even further step back, anytime you're... so what is a scene graph, right? What is a scene graph? A scene graph is a fairly general set of objects that are mutually referencing, right? So it's not just a flat list of things. It's a graph of things that reference each other. And a graph, what I mean by a graph is like not necessarily a scene graph. I just mean it's a bunch of nodes that correspond to objects, and they can point to each other. So once you're at that level of generality, you actually need a fairly general file format to represent it. In particular, without additional structure, a plain old chunk format, like IFF, or I guess the old 3DS format, a bunch of these chunk formats, at least just the first level, they don't have enough structure to represent that. They can just represent these sort of independent chunks. So you need something fairly general to deal with that. And at that point, you're really talking about general serialization. And so that's the approach I took here. So let me talk about what I've done this weekend. So I designed this format called GOB, which stands for maybe game object or game object binary or graphics object or something, I don't know what. And the basic idea of this format is that it can be loaded without relocation. So typically when people have general graph representations of like an object graph or scene graph or something, one approach you can take, and I believe Granny used this for its on-disk format, is that you can essentially write out almost the raw data structures with pointers, like pointers as they were in memory when they were being written out, and then you store some sort of relocation table as a header or footer. And then when you load it, you go through the list of relocations, just like when you're loading a DLL file or an exe file that is not being loaded at its preferred load address, and you do the offsets accordingly to where they're actually being loaded into memory. So that requires fix-ups, and fix-ups they're a little bit expensive or can be expensive. They're also just annoying to have to do. So one way to avoid that, and in fact that's what modern x64 code does, is to use relative addressing rather than absolute sort of pointer style addressing. And by doing that, you can take a sort of a heap, if you will, and you can kind of slide it anywhere around in memory, and the references will still hold up. They'll still resolve correctly because they're all relative. So it doesn't care about the overall offset of the heap. And that's obviously useful for a bunch of different purposes, but especially for serialization formats. Well, I shouldn't even call it serialization formats, because for GOB, it's actually not serializing. It's really just writing it out and mapping it back in. But yeah, so the way that works is instead of having direct pointers, you have these things that are called references. So gob reference is a generic reference, and it stores a signed 32-bit offset, and this could be 64-bit with no change. And so anytime you want to point to something, you have a reference, a gob reference. And a gob reference is relative to the thing itself, and that's something that's a little bit hard to understand. So basically, the way you resolve a reference is you essentially do this. You take the location of the reference L value, and then you add, you convert that to a byte pointer, so you can do byte-wise address arithmetic, and then you add the offset to that. And so that's the idea. I have some simple macros to do that. So this is a simple case here where you're just doing exactly what I just wrote down. And so from that, you can kind of convert at runtime between the relative offsets and pointers that C will work with directly. Okay, so let me just go over some more stuff. Let me just take a look here. So yeah, so the overall philosophy, and this is, I think, fairly controversial that I'm using, is I'm taking raw memory, and the raw memory could be like, it could be generated in memory, or it could be memory mapped directly out of a file. And I'm using the C type system to interpret it in place without copying or fixing it up or serializing or deserializing. Meaning, like, let me show you with my test program. I have this gob file, and I map it. Then I just cast the base pointer of the map memory to header. Header just contains two fields. It contains a standard 4-byte signature, and then it contains a reference, and this is the kind of reference I was just talking about. It's the relative offset. It contains a reference to the descriptor table. And from that reference, I can get a pointer by doing that offset math I just mentioned. And now I have a real pointer, so I went from a relative offset to a real pointer. And now using a real pointer, I can just walk through memory the way I want. Anytime I get to a reference, in order to go through it, I have these macros that that basically just do the offset math and potentially a cast if it's a typed reference. And then I just deal with it like the way I would deal with C data. So so for example, like, let me just explain what this code does if it's not obvious. I map the thing into memory. I find the descriptor table. The descriptor table is just a list of kind of objects in memory along with tags. So I was talking on Twitter a few weeks ago about descriptors. This is exactly the same kind of descriptor. And so I go through and I look for a scene descriptor, and if I find it, that's like my root. So I grab that scene and I grab that as a pointer. So even though I found it as an offset, I now have a pointer to it because it's mapped into memory. So I can do that. And now that I have a scene pointer, when I'm doing my draw stuff, I can just call draw scene on it. So I think I showed this scene graph rendering snippet. I posted the link to the gist on Twitter, but you can see what it's basically doing is it's just doing a recursive pointer-based traversal, but using these converter macros to convert the relative offsets into actual pointers. And as for what the data looks like I said, it's just C structs. Now, the general data with using this kind of approach for a file format is that you end up coupling to the compiler. So what do I mean by that? What I mean is I make assumptions about what these structures will actually look like in memory, because otherwise, if I write them with one compiler and read with another compiler and they disagree about the layout, I'm not going to get the right data back. And for example, if you read a lot of articles about serialization systems, they will dismiss this kind of approach out of hand. I do think it has it has drawbacks, but I don't think for a lot of the cases I care about that the drawbacks are actually sufficient enough to negate the benefits. So things you can do is you can in almost every compiler has pragma pack. So even if the context has done anything but 8-byte line packing, you can enforce that. So that kind of takes the packing context a little bit out of the equation. The other thing, of course, is endianness. If you're dealing with any multi-byte sort of integer types, endianness and memory layout have this nasty interaction. However, there's no platforms I care about anymore, and probably that you care about anymore, that are big endian. Like the last one was PowerPC. ARM in theory, I think, can at design time be configured to be big endian, but I don't think any of the widely used ARM chips are big endian. Certainly none of the ones I care about. So endianness is not really a practical issue anymore. It was back when the 360 and the PS3 were still an ongoing concern, but not anymore. They're kind of a theoretical concern, not a practical concern. So that's my primary, that's like 99% of my reason why I don't think it's an issue. The other thing you can do is anytime you're doing these sort of direct mapped approaches to file data, you can always just treat what I'm doing here as a fast path, but have a fallback path for platforms that can't guarantee the same data layout. So if you're on a platform that's big endian, for example, you can do what I'm doing here, but then do endian swaps at load time. So that'll be slower, but that hopefully represents like an extreme edge case. And all the platforms that you probably care about don't have to do that. They can just map it directly and go about their way. The other thing, which is not really an issue unless you're careless, is that you have to make sure you don't store any data structures in here that are dependent on the native pointer size. So I never store, for example, or not even native pointer size, but things like unsized types, right? Like so void star, 4 bytes on a 32-bit machine, 8 bytes on a 64-bit machine. Actually, int is not a great example. Like I think all the compilers I use nowadays, int is always 32 bits. But certainly there was a time when certain compilers during the shift to 64-bit in maybe the early 2000s or late 90s, where some compilers had a 64-bit int. So just for safety, always used explicitly sized types. All right. But yeah, but the nice thing about this approach is that you don't have to have like a separate IDL that describes data layout. You literally just use C types, and you have to obey these few precautions, and you're good. So that's kind of the idea, and maybe we can trace through what this draw call code does relative to the data structure. So a gob scene has a node reference to a root. A node reference is just a reference the way I described earlier, but it's typed. So it does a little bit of type checking when you try to kind of do the offset math to make sure that it doesn't cast to an invalid pointer type. A node is essentially just a scene graph node. So it has a kind, so it can either be a mesh node, it can be a plain transform node, which is essentially just has no payload other than a transform and a bunch of children. It can be a mesh node, in which case it has a mesh reference. It can be a light, in which case it has a light reference. It can have a name. It can have a transform, and that's not a transform reference. That's just a transform. So using the C-type system, this is stored inline, inside the struct by value. And this is sort of an interesting point because this is something that I use throughout. At the end of the struct, you can have a variable amount of data. So this array of size 1 is just essentially a way of saying, hey, this is an array. But in reality, this is going to be variable length, and the children count is going to specify how long it is. And you need this for things like, vertex buffers that are variable sized, and it's also convenient for things like this gob node where, instead of having linked lists to store a variable number of children, you can just have a flat array here at the end of the array. And this is something that works really well with C's type system. Like people already traditionally do this for C code even without looking at file format stuff. So this works really well for that. If you look at mesh reference, or not mesh reference, just gob mesh. Gob mesh is an encoding of a static mesh. It's a little more complicated, but it follows the same overall pattern. There's a mesh topology, which is just like, is it a list or a strip? There's a buffer view, which I'll get to in a second. That's like a view of a buffer, so it has stride and length and stuff like that. An index buffer view, which is the same kind of thing, but also stores information about whether the indices are 16-bit or 32-bit. And then again, we have this variable amount of data at the end, which is the section. So a mesh section basically says, hey, even though the mesh data all comes out of the same index buffer, you might want to have separate slices that have different materials. So you can have different materials within the same mesh. So that's like a standard thing, and that's how this is encoded. So you can see how nice this is. Like it's literally just C data types. There's no functions to do any serialization or anything. All you have to do to use this kind of data is you need like raw memory that stores it, and then you need these kind of macros which do some very mild arithmetic to compute pointers from offsets, and that's it. You can see how mild the additional, like if we were using direct pointers rather than relative offsets, all you would have to remove are these gob underscore foo macro calls. But otherwise, this is exactly how you would write it if everything was a direct pointer. And again, this doesn't have to run memmap zero-copy out of a file. You can definitely, like for example, if you don't want to pay the seek cost of jumping around in a memmap file, you can just do a single f read up front and have no seeks. So you have the ability to do that, but you have the flexibility to do this as well, where it's just directly mapped. So yeah, I'm not going to go over the details. This is standard scene graph stuff, but I think it's nice how directly and compactly you can encode this. And I kind of enjoy the fact that there's actually no function definitions in this header file. This is the definition of the whole format, but it has absolutely no functions. It just has type definitions and a very mild amount of macros that do some offsetting. So yeah, so that's the format. I want to talk about my exporter because I wrote as a way to test this, and also something I hope to develop later into. Oh, actually, let me show you my rendering app first. No, actually, let me start with the exporter. So, and let me open something else. So this is UE4. Yeah, so someone's asking about undefined things about accessing beyond blah blah blah, and I think you're probably right that it's technically undefined behavior. On the other hand, this is so widely used. Like for example, well, I was going to say the fact that the Win32 API uses this extensively for doing variable length data, that's not a guarantee that it's not undefined behavior, but um, yeah, uh, it's a common enough trick that I would be surprised if most compilers would fuck with it, or even any compilers in wide use, because this is such a common trick. Like not for serialization necessarily, but just as a way of kind of flattening, you know, for example, if you have a buffer prefixed with a size, this is sort of a nice way of doing that. Anyway, okay, so my UE4 scene loaded. This is just one of the default example projects in UE4. So this is the scene in here. You can see, I mean, I'm not going to go over UE4, but anyway, it has has some scene hierarchy both at the actor level and also at the component level. So if you open, if you open any of these actors, if you open any of these actors, it also has an internal component hierarchy. Or maybe not so much in that case. Oh, you can see it down here. Yeah, so you can see that this is like the top level actor layout scene graph, and then there's also among the each actor has a component hierarchy, which you can see here, and that's like a transform hierarchy and stuff like that. So yeah, I put in this big ugly button to do the GOB export, and when I click it, I get the export, and let me just open it in my debug renderer. So this is like the ugliest thing ever. So anyway, this is I don't have the rotations right. I should say I have the transform hierarchy, at least the translations, but there's something in UE4 that's causing it to export 0 quaternions, and so it's just a small bug I'm going to fix after the stream. But anyway, you can see it's the whole scene but rotated because I didn't apply the transform correctly. But all the translations are roughly right. This is just kind of looking at everything sideways. I think that's also just because of a coordinate system difference between GL and UE4. So anyway, that's the scene we were just looking at exported, and it uses GOB. So let me go over the UE4 code for the exporter, just briefly. So the whole exporter, and right now it only does static meshes and transform hierarchies, but the whole exporter is like a few hundred lines of code. Most of it is extremely straightforward. I mostly want to focus on the GOB specific parts. So the way it works is you get a U level, which is just the currently edited level. You do an export level, and that recursively exports everything inside it. So if you guys have written kind of general graph serializers before, like the basic pattern you use is that you have some sort of hash table that maps from, in this case, I'm basically exporting from U level pointers to GOB scene pointers. And because of that, in order to handle, like things that refer to things that have to maintain pointer integrity, I use these remapping tables. So anytime you finish exporting a component or a static mesh, it basically caches, it stores the cached map from the original static mesh pointer to the GOB mesh pointer where the corresponding counterpart has been exported. So other people can just point to that place rather than, re-exporting the same thing. And also preventing cycles that cause infinite loops. So the basic pattern of this thing, like I said, is like it's a recursive thing that on entry to any function checks whether the result has already been computed, and if so, it just returns that. Otherwise, it basically, well, this is a complicated maybe case to start with. Okay, no, that's pretty good. So export component, a component basically will correspond to nodes in my GOB file. And all it does is it recursively exports the children, only the children that result in a non-null result. So for example, we don't necessarily want to export all components. There are components that don't have any mesh data or any other payload that we know what to do with. And so we could just export pure transform nodes without any leafy payload, but that doesn't seem very useful, so we just ignore those, or I choose to. So we recursively export all the children, and that gives us pointers to gob nodes. Um, and then once we've done that, and then we have to see like, hey, is this a static mesh component? And if so, we also have to recursively export the static mesh asset, and set the flag, the type flag accordingly. And so assuming basically that we have a non-pure, we either have payload or we have children that have payload, we export this node, and we have this gob allocate node thing, which basically just bumps the pointer forward by the size of the node given this amount of variable data. So this flag, or the second argument, specifies the variable number of children that is in the node, which are part of the, they're, like I said before, they're part of the suffix of that struct. And then I really just, all these calls all these export functions return pointers, but in order to actually store them into memory in the gob file, I have to convert them to references. So I have this function setReference from pointer that takes a pointer and converts it to a reference. This just does the offset math for converting references to pointers in reverse. So it's extremely straightforward. So you can see this is, like, admittedly this is not complete. This only does a subset of the UE4 data types, but you can see how simple this is. Some of it is just being straightforward with the UE4 code, but also the GOP specific code is extremely straightforward. There's really nothing to this. So that's nice. Export transform just converts between those two data types, more or less isomorphic. Actually, completely isomorphic the way I do it. To export a static mesh, it's the same general idea. You have to do some recursive buffer exports for the position buffer and the index buffer, and then you have to store the variable number of sections depending on how many different mesh sections there are in the UE4 mesh, and then you're done. Right now, I just return null for all materials because I haven't gotten that far. Buffer is just like a generic byte buffer, so for vertex buffers and index buffers, they just use this function. And so they all follow the same general pattern. Let me just talk about what you do when you're done. Oh, actually, let me talk about initialization first. When you initialize, right now I just allocate a 1 gigabyte buffer, and then I just have a pointer that starts pointing to the beginning, and then just linearly increases through the buffer as you're writing out objects. And then when we're done actually exporting everything, or rather when we're done exporting the level, which recursively exports everything in the level, we do this write to file. And the last thing we do before actually writing out the file is we export the descriptor table. So the descriptor table describes all the top level kind of heap objects, if you will, that are in the file. And so I just go through all my cache tables and create descriptors for those things in the table. And then I write out the descriptor table. And the descriptor table is another variable length struct, but it's otherwise just another object in the gob file. And so having done that, we then have to go back in and update the header. So there's this header of the whole thing, and the only thing the header stores aside from the signature magic cookie is a relative reference to the descriptor table, because once you have that, you now have a handle to the whole file. Basically, like from there you can recursively find everything else. And so having done that, we now just have to do a single write file because everything's already linearly laid out. There's no fix-ups or relocations on export. It's the same as on import. There's none of that. It does it, well, I guess you can say that each of these set reference from pointer calls is sort of a relocation or whatever, but it does it sort of as it's processing the data, not after the fact or whatever. So yeah, that's the whole exporter. It doesn't do every kind of data. It does static meshes and transforms basically. And only even positions for static meshes. I don't do normals, tangents, or text chords, although that's easy to add. And if you look at the gob.h, you can see I already defined data structures for those to slot in, but I just wanted to show it on stream since it already demonstrates all the principles that I wanted to demonstrate. So yeah, so that's the whole thing. It's pretty simple. And I think that's about it. Let me go and catch up on chat and see if people have questions. And if people have new questions, we can talk about those as well. Sorry, this was like a super discursive, maybe semi-incoherent walkthrough of stuff. I hadn't really prepared the discussion. I was just talking about random stuff that came to mind. If anything is unclear, ask me questions in chat, and I will try my best to answer it. I'll mention one little safeguard trick, which is optional, but it's there for safety. If you're in C++ 11, so you have support for deletable constructors, I do this thing to prevent copying of references, and the reason is because references have this kind of, they have this self-relative property. If you do a copy by value of a reference, it will now resolve to garbage because the location of the new reference value is not where the old one was, and so the offset is not, you'd have to relocate the offset accordingly. So to prevent that, I have this disallow copying macro, which on C++ 11 capable compilers will delete the constructor. Yeah, so gob.h is the entire. Someone's asking, is gob.h an entire library? That's right. It's a completely self-contained library. For the exporter, let me just show that. The exporter has a few extra macros, and I would probably put these in like gobwriter.h, but really all they do is bump a pointer by the size, do pointer alignment between objects and stuff like that. But these are the only other macros you need for export. I didn't want to put them into gob.h because most people are not going to be exporting, they're going to be importing. Someone else was asking, the 1 gigabyte alloc thing, would it be possible to make sure you don't access old pointers and use realloc? Not sure what you mean. Like, the 1 gigabyte alloc is just because I'm being lazy. You can do a bunch, you can, like, you certainly, like, the GOP file format assumes that everything you're doing is linear. So you'd probably want to, like, I would say the only issue with the way I'm doing it here is that I'm pre-committing the whole range. Ideally, what you do is that you would make maybe so for example, 2 gigabytes with 32-bit assigned offsets. 2 gigabytes is the largest you can go with a GOB file. You could do a 2 gigabyte reserve and then incrementally commit it as needed. And then basically all you'd have to change is that these allocate macros would have to do a check to see whether the increased pointer is beyond the commit limit, and then increase the commit limit if so. But the idea is that you do these very generous reservations, incremental commits based on usage. Then once you're done, you just dump the whole thing after you've written it out. Someone's saying if I put in a linker error. Yeah, the reason I didn't want to do that was because I was afraid of it making it's going to delete all the normal constructors. I think once you add a constructor, all the normal C behavior for data structs disappears. And also, yeah, and I still want it to work for plain C, not just for C++. So I thought this was probably the best trade-off. Where's gob.h? Here we go. Realog as you go. Yeah, it's certainly true you can realog as well because all the offsets are relative, so you don't have to do relocations. But clearly, the modern way to do this is to do a big reserve and then do incremental commits. So then that way you never have to realog. And at least on 64-bit systems, that's the way to do it. But if you want to do the realog way, it's going to be much more expensive for very large files, large scenes. But yeah, it totally works. Yep, you're right. Realog works. All this stuff is relocation, location independent, position independent. Yeah, someone's saying that the 1 gigabyte commit isn't actually using a gig of physical. I mean, that's true, but it still counts against the commit limit. And the commit limit, even though it's just a number going up and down, it still counts, right? In terms of your available memory is basically, let's see, physical memory plus page file, right? So anyway, it still counts against the limit, but it's certainly not an issue in practice. I agree. Like it's not actually forcing in, it's not committing in 0 pages or something crazy like that for that 1 gigabyte of pages. Okay, version changes. How to handle, if at all? Well, you would probably, there's different ways you can handle version changes. Probably the easiest, honestly, is just to create entirely new structs. So let me see. So right now, you have this notion of descriptors. and a descriptor is essentially just a combination of a reference and a type. And a type is just a 4cc code. So you could easily just append, you could cannibalize, say, the final number into a version code or something, or you can even add like a separate version if you wanted. So the way I would do that is not by trying to kind of extend the existing structs in place. I would do it by adding entirely new data types that replace or augment the existing data types. I think in general, if you're going to do file format binary compatibility, something like that is the way to go. Because yeah, and at some point the basic meaning of the data is also diverged enough that um, you probably want to kind of fork in some sense anyway, and not try to just build on top of existing stuff, but just replace it with new data structures. And I should also mention that version changes, while totally doable with this approach, is not like the number one design forcing function. It's something that's totally supported by this approach, but it's not like optimized for rapid changes. I should also mention one thing that you can totally do, and that I probably plan to do once this gets a little bit further along, is that you can have self-identifying data where rather than just having 4cc codes that the reader is expected to know what it means, you can have the 4cc codes, you can have like type descriptors. And type descriptors would be like, hey, here's I talked about reflection systems like Sino and stuff like that before. You can totally have that kind of metadata description as an item in the file, which makes it more like XML or JSON in the sense that everything is self-describing in terms of the fields and their basic sizes and semantics. Like, is this a float versus an int? Is this a 2-byte int versus a 4-byte int? That kind of stuff you can totally encode in a metadata schema that goes along. And given that, even someone who doesn't understand the meaning of that data at least has enough of the skeleton of, here's the fields and so on, that he can do something with it. And at that point, you have all the same properties as, say, XML or JSON. And those are nice properties to have, but yeah, you can do it just as easily, or maybe not just as easily. You can do it very easily with this approach as well, and you don't have to do text parsing or any of that crap. Anything else? Let me actually go back and chat because I think I missed a bunch. Do you see this being used by large-scale 3D programs? I mean, realistically, not. Um, like, this is for my own usage, but so let me just say something about in general by the things I write on stream and put up on the gist or whatever. I don't generally expect people to use anything I write as is. And in fact, it's often, with a few exceptions, it's mostly either intended as a proof of concept or something to force myself to think through a design or programming problem, or it's intended as an example to other people, right? Like, here's a way to do it. Like with some of the Muse stuff, it's like, here's a way you can design a platform library that's maybe different from how you're used to it. With this stuff, it's like, hey, here's a really nice, compact, efficient, cool way you can do asset formats. I should mention though that game studios do use relocation or like position independent asset formats. I just haven't seen it used for something more general intended for interchange like this. So I think that's maybe the extra thing. I also think the specific implementation I have here is very nice, but that's obviously a personal bias. Someone was asking, the descriptor table is just someone's asking, the descriptor table is a list of top-level objects. That's right. It's just the top-level objects. And in fact, it doesn't have to be a complete list of top-level objects. It just has to be sort of, if you think about like a DLL or something, you can think of this as a list of exports. They're only the top-level objects you want to expose. And for example, it would actually be perfectly fine to only have a descriptor entry for the scene, because from the scene you can reach everything else. But I do choose to export everything else just so there's a little bit more metadata about the heap in the GOB file. But yeah, in theory, you would actually be fine just exporting the root, but I made it more general because it's easy and convenient. Someone's saying I've made something like this before. It's helpful to have sections. So I'm assuming you mean like sections like in a DLL or a P file, like a P or ELF file or something. So you can allocate memory for a different memory bus for certain platforms, or you can have editor sideband data. Yeah, that's definitely nice. So basically, like sections are like, I guess one way to think about sections is they're just different heaps that happen to live in the same file. So something like this data format, you can totally just append different heaps and have a header that points to each of them with a tag, so you know what heap is which or what section is which. And that's, I mean, that's how PE format, that's how ELF format essentially works. You can do the same thing here. It's pretty easy to do that. Didn't run into a case where I really wanted it, but I can totally see how that would be useful. Yeah, thanks. Someone's asking about the interquake model format. It requires a few copies and can only hold one skinned mesh, but I thought it looked promising. No, I haven't looked at that. I mean, there's a lot of mesh formats. I think the more interesting thing is actually scene formats, of which there are a dearth for game use. Someone's asking about a GOB file in a hex editor. Sure. Okay. For some reason, I thought Visual Studio had a hex editor, but I'm clearly high. Do I even have a hex editor? I guess I have Sublime. 1 second. Sublime is not a hex editor, but it will display stuff in hex. So, yeah. I mean, yeah. That's what it looks like. It's fairly compact. It's obviously, like I would say that one thing that's hard to do with this approach is bit packing. Now you can use C support for bit fields, but that's, you know, a little bit suspect. I think that's part of the that's part of the danger zone in terms of compiler incompatibility. Whereas I think the other things I rely on are mostly safe. Between, for example, MSVC and GCC. I don't know how MSVC versus GCC versus Clang packs C bit fields. So anyway, yeah, that's what it looks like in hex. It's not, I mean, not much you can see when it's just hex. All right, someone's saying you can actually use Visual Studio as a hex editor. Yeah, that's what I thought I did. Okay. Someone's asking, any idea how well this type of data compresses in SIP, for example? No idea. I would say that one disadvantage of relative offsets is that they're less obviously repetitive. So for example, if you have a bunch of pointers and they're using absolute offsets relative to, say, the base of the file rather than relative to themselves, um, there's going to be a lot of, I mean, actually, here's a classic example. Null pointer. How do you encode a null pointer? So relative offsets actually work perfectly well for encoding null pointers. I saw Juan was asking about it on Twitter. You don't have to treat them specially because it's just math, right? Like all that matters for the encoding, decoding thing to be lossless, modulo 32 bits or I guess 64-bit or whatever you have for the offset size. It just requires the invertibility of those two math operations. So you can encode null pointers just fine, but they'll be encoded not as a 0-bit pattern, but with a relative encoding that adds up to 0 when added to that the location of where the offset is stored. But suppose you have a lot of null pointers in a file. After doing these relative offsets, they're now not going to be 0 anymore in memory. So if you have, for example, like a huge table just of null pointers, all of them are going to basically be, now they're not going to be 0 anymore. They're going to be something else. So that's potentially an issue. However, if you look at the data that makes up the bulk of a scene file, it's mostly vertex buffers and stuff like that. And those don't have any relative data, right? They're just, vertex properties or whatever. Someone's asking, I'm assuming this format just references texture images by asset or file name. So I haven't implemented textures, but I thought through all these different asset types like textures and skinned meshes and stuff. I was planning on just having actually textures be RGBA or DDS directly, or like raw pixel format directly in the file, and you can certainly have the option of having externally referenceable things like the way that I guess OpenGX and gltf and other formats do it. The reason I don't want to make that a basic thing actually is that, again, it means that if someone gives me a GOB file, I now have to have an embedded ping reader or an embedded JPEG reader. I just want to be able to hand the fucking data to the API, and if GOB gives me just an RBGA array, I can just pass that directly to GL text image 2D and I'm off to the races. So a lot of this stuff is sort of designed to make it very kind of easy to just pass it to the API. Um, and again, I have this philosophy that if you add in needless flexibility in the format, it means that every reader now has to potentially deal with that flexibility. And so, you know what? I might actually not allow externally referenceable like JPEGs or PNGs or something. I'm probably just going to force them to be embedded. And the embedded one can be DDS, for example, but just some directly API readable format. Someone's asking, would you write an entire tool to treat a GOP heap as the working set, or do you expect to have to copy data to new reallocated memory block for export? Um, so you mean for export specifically? Um, no. Like the other thing I should mention, by the way, is that even though I've kind of emphasized the zero copy mem mappable aspects, I don't want to overemphasize it. I think it's a symptom of a very nice property, and for very large heaps, it can be nice to be able to do random access. Like for example, suppose you have like a 100 GB heap, which is totally possible with like with VFX situations. It's nice that you can kind of drill down random access style. The downside is you're drilling down random access style. So for more moderately sized things, you actually do just want to do a single F read. Um, and so, yeah, it's less about. I would say for me, it's less about that. Although that's a nice property that you can mem map it without doing copies, and it's more just what it says about the basic design of the format and how it makes it easy to put it into a file. Like I'll mention a bunch of examples that you can do very easily with this kind of approach. One app can communicate directly to another app using IPC. So, for example, suppose you have an IPC channel, like this would be like name pipes on Windows, and then off to the side. So the name pipe would be basically for messages, but then you have like a shared memory section between those two apps, and the exporter writes directly into the shared memory, so the other one doesn't have to round trip. You can very easily do that with this format because the receiving side doesn't have to deserialize. And in this case, there's no kind of disk round tripping, so you don't have to worry about, seek overhead from doing random access I/O. Another case is doing so that was a case of using shared memory to communicate. You can also imagine using a network socket where you're just writing it to a stream, and in that case, you have to buffer the whole thing because it's a stream. So you in order to read from this, if it's communicating off stream, you have to buffer the whole thing. But still, it's just like a big, it's just a bit like sucking it into a buffer over the network, and then once it's done, you can start doing stuff with it without doing any fix-ups or parsing. Very, very nice to have that property. It's just plain data that you can pass over a socket or through a shared memory range or anything like that. Someone's asking if I prefer VS or Emacs. Visual Studio for C++ for sure. Maybe at one point I tried to write a bunch of stuff like my own debugger for Emacs on top of GTBMI and stuff like that to try to make it better for C++ development. For me, the number one thing, so there's like two big use cases for me doing C++. Either I'm doing home projects, in which case the most important thing is the debugger. And so having good debugging is core for me. Um, uh, if I'm working professionally, the debugger is also really important, but also having good kind of visual, like basically having Visual Assist X available. Like if I'm working in UE4, there's no way you can work on UE4 without Visual Assist X, or you're just gonna spend half your time trying to find shit. So kind of for those dual benefits, for the kind of work I do, both as a hobbyist and as a professional, Visual Studio is really the only game in town. Unfortunately, I would really want things to be different, but C++ is sort of a complicated language to build tooling around, so there's no real alternatives on Windows at least. And even the stuff I mean, there's Qt Creator, which works on Windows. There is the new thing from JetBrains called Sea Lion, which I guess could eventually get there, but certainly isn't there yet for the debugging parts, and just doesn't work with large code bases, right? Like try opening UE4 and Sea Lion, and you're gonna like destroy your computer, I'm sure. Like last time I tried stressing C-line with large projects, it shit itself even for like 100,000 line projects, which is a very small project in my opinion, like for professional use. So there's really no good alternatives to Visual Studio, alas. I know some people use Visual Studio just for debugging and others for editing. Um, I used to do that too. I know Casey does this, and maybe John Blow. Um, I don't know. The context switching of that I find awkward. I spend all my time in the debugger when developing code. Like I'm constantly rerunning and breakpointing and run to cursor and all this other stuff when I'm developing code, especially at home. switching between the Visual Studio app just for debugging and Emacs for text editing probably isn't, well, just it's awkward. I don't like it. All right, seems like the relevant questions are drying up. If anyone has any final questions, I will wrap up. Trying to see, remember if there's anything special I do here for the exporter. Don't think so. Like, I'm pretty happy with how simple the UE4 piece of this turned out. I think that's sort of a testament to the basic design of GOB, but also, if you have sort of a get in and out approach to doing this stuff, things are really straightforward, and you're not really doing crazy data transformation to do exports. Of course, in this case, it's because UE4 is, it is a game engine, so it's not a DCC app per se, although it's getting closer and closer to a standalone DCC app with some of the latest stuff for animation, but it's fundamentally a game engine and it's Genesis, and so the way that it stores and represents data is much more congenial to this kind of exporting. I will also say, by the way, that I think a fully featured version of what I'm doing here, which I plan to write gradually as the need arises, that can export animations and materials in some useful way, and everything really, that sort of generic scene graph stuff. Having that and an easy way to load it into testbed apps would be huge, because UE4 is a really, really good level editor layout tool, and doing it this way, you can kind of preview stuff, basically using the UE4 renderer and editor. And then if you want to do rendering experimentation, you can just do a full scene export and, or for game development, for bootstrapping your own game before you have an editor or something. And at that point, you're basically using UE4 more as a preview and editing tool than as a game engine. I actually think that has a lot of promise as a way of bootstrapping things, but I'm not there yet. This is just a showcase for just for static meshes and transform hierarchies. So anyway, unless there's more questions, I'm done. All right. Someone's asking about going to release the source code. I mean, maybe not the UE4 parts because they're kind of entangled with stuff and not very useful um, as is. But I'll release the gob.h stuff and just to show you guys. There's like you saw everything on the screen, but I'll totally post it. Yeah. So anyway, thanks for hanging out. If you have any more questions, I'll try to hang around in stream chat for a few minutes after and tidy things up. So thanks for coming by.